Okay, so in chapter 6 here, they give this motivation and they say we want to look at equations of this sort right here, so this quadratic. So ax squared plus 2hxy plus by squared plus or equals c. And they say not all of A, H, and B are 0, so at least one of those is not 0. Then they say, okay, this is called a quadratic form, and we could write it in a matrix form like this with our variables x, y here. So this is x transpose AX. And so then they they very quickly immediately here get into talking about rotating things through theta radians, okay, to new axes. And so I just wanted to go to Desmos to kind of show what they're talking about here. If I plot ax squared plus 2hxy plus by squared equals c, and tell it to go ahead and fill in those parameters a, b, and c, it set them all to 1, but I messed with them a little bit here. I'm going to just keep c at 1 and h at 0 for the moment, and probably b at 0.6, just to kind of show that if I start moving a here, then what we get for some values of a is this ellipse. Okay, so we see an ellipse with a major axis vertical here and the minor axis horizontal. Now I could change that simply by making b bigger than a. Well, actually, I'm gonna, I'll go like that and then bring a down. Whoa, too far. So there I made the major axis go horizontal by making b bigger than a. And if I change those, if I all of a sudden make a negative, then we get this hyperbola, and we can get it going the other direction by making a positive and b negative, like that. So we can get these various shapes. If I make b 0 and start messing with h, we can get parabolas and that sort of thing. So those are the figures. These are all conic sections that we're getting out of this equation. And now let me go back to an ellipse. That's a good one. And so they were talking about rotating. Well, see, if I have an ellipse oriented this way, so that for instance, the 1.8 x squared, now h is 0, so there's no middle term here, and then plus 0.1 y squared equals 1. I know a lot about those ellipses. I can find areas, I can find perimeters, I can do all sorts of nifty things. However, it starts to get a little more complicated. If I mess with h here, notice what happens is, that at first when I start moving h, I still have an ellipse, but you see it's rotating. And if I take it too far, then I get a hyperbola, but it's also still rotating. The axes, the major and minor axes that go through, for instance, this ellipse, they're no longer lining up with my x and y axis. And so that can make life a lot more difficult. And so that's the idea of what they're talking about when they want to rotate these things is we want to look at being able to get this thing back to something that looks more like that, because then I know what to do with that. Okay, so that's I just wanted to do a short video to kind of talk about what they mean by that rotation. So we're looking at these various possible conic sections when we look at something like that, this quadratic form. And so when we're doing that, again, we know, you can look in your calculus book, you see all kinds of nifty results for these different conic sections, as long as we have them all lining up with the major axes, the x and y axes. As soon as they get rotated, as I said, things get a little tougher. And so the idea of manipulating the object and rotating it back, so if I had that and I want to rotate it back one direction or another, I want to rotate it either so the long axis is on the y or the x, doesn't really matter. But if I want to rotate it one of those two ways, I need to kind of start looking at that idea. So that's the motivation, is we know a lot about this form when it is not rotated, as we see here, but when it's rotated again, it starts to get a bit more complicated. So we would like to kind of look at ways to rotate it back to a certain orientation to help us. Okay, so that is this idea of a quadratic form and rotation.